Alright, so we're on our next video, and this is solving quadratic equations using the quadratic formula. First thing you need to do is know what the quadratic formula is. The quadratic formula is this guy right here. X equals negative b plus or minus the square root of b squared minus 4ac all over. Everything's divided by 2a. There is actually a nifty derivation of this using the difference of, sorry about that, using completing the square. And when you use completing the square and you use the techniques of using the square, completing the square, you end up with this formula. So what you need to do is you need to label your A, your B, and your C. Once you do that, it's pretty much impossible to go wrong. And actually, you know what? I'm going to change one thing. I'm going to make this into a negative 5. And I have my reasons for that, but don't worry about it quite yet. So that's a negative 5. Go back to this pretty color, make that my C into a negative 5. So all you have to do is write down the formula exactly as you see it, except I do something which I think is clever, but I'm sure other people will argue against. And I just put in parentheses instead of numbers, and then I just fill them in. So now it's negative b. Well, my b is negative, so that's going to become a negative 3. This becomes a negative 3. And the reason why is because that negative 3 is now in parentheses, and that's the negative 3 squared. For a, it's going to be 2. C is negative 5. Once I do that, I say negative and negative is positive, plus or minus. That's going to be a 9 minus 4 times 2 is 8, times a negative 5 is a negative 40, so minus a negative gives me a positive. Oh, goodness me. All over 2a, which is 4. And then I get x equals 3 plus or minus the square root of 49 over 4, which is kind of funny because this actually works out, and I just made this question up. So x equals 3 plus 7 over 4, or x equals 3 minus 7 over 4, and I get x equals 10 fourths, which is 5 halves, or x equals negative 4 over 4, which is negative 1. I'm going to do another example, and hopefully this example won't work out quite as nice, and possibly even have some nightmarish things happening. So I'm going to erase this. And the nice thing about this being a video is if you didn't get that, pause the video, go on back. So let's take a look at another one, and like I said, hopefully something bad will happen. Let's say I have x squared minus 4x plus, I don't know, let's say 12. So once again, I'm going to say my a equals 1, my b equals negative 4, my c equals 12. Yes, this is going to be a good one because it's not going to work well. So I got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I plug these on in. Negative 4, a is 1, c is 12, and a is 1. So I got x equals negative and negative gives me a positive, plus or minus negative 4 squared is 16, minus 4 times 1 times 12 is 48, all over 2. Now I have a problem. I have x equals 4 plus or minus square root of negative 32 over 2. You cannot have a real solution with a negative underneath the radical sign. So here, there are no real roots. You're done. If you have a negative underneath the radical sign, you're completely stopped. I'm going to do one last thing, and I don't want you guys to get confused, so I'm going to erase everything. And I want to show one last piece of information. let's say it's something like this. X equals 4 plus or minus the square root of 32 over 2. Well, radical 32, and this is completely separate from everything else. Square root of 32 is really square root of 16 times square root of 2, which really means that's 4 radical 2. So you'd end up with 4 plus or minus 4 radical 2 over 2. Because 2 goes into 4, into both, I got 2 plus or minus 2 radical 2. And so your two solutions, hold on Benji, hold on please, is 2 plus 2 radical 2 or 2 minus 2 radical 2. And that's it.